So this is an introduction to the table method you can use even in algebra. And the idea is simple, that you start with, let's say, a table. So you say, let's do 2 times 2, 2 times 3, 2 times 4. So if you're writing like the two tables, then this is 4, this is 6, this is 8. And then 3 of these in 3 tables, 3 times 2, that's 6. 3 threes are, 3 fours are, 4 twos are, 4 threes are, 4 fours are. So you have all these results and you just write it in a tabular form as a table, as a 3 by 3 table. So you are doing the 2 here. So 2 twos are, 2 threes are, 2 fours are. So this one will become 4, 6, 8. Maybe I can use a different color for this. So this one will become 6, 9, 12. So I have the next column 6, 9, 12 based on 3. So it's the same because we are doing a square and square root, the numbers will be the same. 2, 3, 4, 2, 3, 4. And this will be 4 twos are. So that's maybe another color. 8, 12, 16. So 8, 12, 16. Okay. So this is how a table is made. If you take any row and any column, it's 3 times this. So this number is 3 times 3. If you take, for example, this number, this is 2 times 4. And when you look at the patterns, you observe something very obvious. The first is that these two numbers are the same, because this is 2 threes are and this is also 2 threes are. So whether you look at it this way or whether you look at it this way, these numbers will be the same. Similarly, these numbers will be the same. 3 fours are and 4 threes are. And also these two numbers will be the same. So this pattern repeats whenever you do, whether it is in this, whether it is in algebra. You have these two the same, these two the same, those two the same. The unique ones are, you can see this one is only one of them, square of that, square of that, square of that. So you have 3 things that are squares and these 3 that are repeated. So this is the first thing that you can do when you are introducing the table method for square root, even without algebra, just in terms of how you can compactly write a table. So if I wanted to square an expression 2x square plus 3x plus 4, then that's what this table represents. So you will have 2x square, 3x and 4, 2x square, 3x and 4. Okay, so this box will represent x square plus x square, so that's 4x to the power of 4. Okay, these two will multiply to the same, and this is 6 times x cube. Remember, these two will be the same. Another good thing to remember is that this will be x cubes. Both these boxes will be x cubes. Okay, both these 3 boxes will all be x square. So you don't really need to think of the x too much when you multiply. These will all be x square. And the next box, this box, they'll all represent x. So you can just put x. And this will be a constant, so it will have no x. Okay. So even without working it out, you know what to expect. Yeah. So now we know this and this will be 8, and we know 8 will come here as well. These two are the same. And 3 and 3, so that will be 9. Again, 4 times 3 is 12, and both these will of course be the same. And then 4 fours are 16. So the same table you had here now, all you do is you are looking at these diagonals and saying this will give you 12 of a same color if I use, so out of 12 times x cube, this will give you 8 plus 8, which is 16. 16 plus 9, 27. That's 27, that's an x cube. X square, right? And 12 plus 12, 24x plus 16 and 4 times x power 4. So this is the result you get when you square this expression. This expression squared is this result. Okay, so now if we know that this is a perfect square and I want to find out what the square root is, I can use that table method. So the first thing I know is that this one is 4x power 4. I know this one expressions will have x square, x and nothing, and x square, x square, x and no x. Okay. The question is which square will give 4. So what's the square root of 4? 2. So this will be a 2x square, this will be a 2x square. Only then you will get 4x to the power of 4. That's when you get 4x to the power of 4. So this is clear. Now these two boxes will have the same number. You can split 12 into 2. So there will be 6. Of course we know this is x cube. Remember this is x cube. This is x square. And this is x. So this is x cube. This we are clear. So because this is x cube, you will have to have 6 here and 6 here. Okay. So now it's just a matter of looking at, okay, 6 is there, 2 is already here. What else do I have to multiply to get 6? 3. So these two becomes 3x. So 3 3s are, that's 9. So that's 9. Sorry. 9x square, and we know there are 2 more terms of x square here. So this is 9x square. Total is 27. From 27, if I remove 9, I will have 18 left. If 18 I split into 2, I will have, this should have been 25. So if I remove 9 from 25, I will be left with 16. Half of that is 8 here and 8 there. So now the next 2 and 8, what I do have to multiply with 4. So that's all that's left. 4 4s are 16. I can write 16 here. Yes, that is correct. And 3 4s are 12. This will be x's, of course. So 12x. 12 plus 12, 24. It is a perfect square.